Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we finished exercise 11.4. The topic of that exercise was geometric sequence, a sequence whose ratio is same. Today we are going to start exercise 11.5 and the topic is infinite geometric series. The series is geometric just like in exercise 11.4, but it is infinite. Infinite series means first end, we know the first end of the series, but we don't know the last end of the series. For example, okay, first I want to read the page you can see on the screen. An infinite series is a series whose terms continue forever. The geometric series where a is equals to 2 means the first term and the ratio is half. Is 2 plus 1 plus 1 upon 2 plus 1 upon 4 plus 1 upon 8 plus dash 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 dash. It is continue forever. But we can sum this series. Interesting, isn't it? We don't know the last term of the series, but we can add. Why? Because the series is convergent. Series is convergent. I will not tell more about the meaning of conversion, but I am giving you the formula of sum to infinity of an infinite geometric series is S subscript infinity sign is equals to a upon 1 minus r, where a is the first term, r is the common ratio. This formula tells you if you have first term and the common ratio, then you can easily add infinite geometric series. Let's start exercise 11.5 question number 1. Find the sum to infinity of each of the following geometric series. Part A. So part A is 3 plus 1 plus 1 over 3 plus 1 over 9 and continue forever. What is the formula of sum to infinity of geometric series? Sum to infinity is a upon 1 minus r. So first write a is the first term, that is 3, then r common ratio, divide any preceding by its following, that is 1 upon 3, and the formula of sum to infinity is equals to a 3 upon 1 minus r, that is 1 upon 3. So 3 upon 3 when the 3 minus 2 is 2 upon 3, or 3 multiplied by 3 directly, 9 upon 2 is 4.5. So converge at 4.5. This is our final answer of part A. So very easy question. Come to part B. Part B is 1 minus 1 upon 2 plus 1 upon 4 minus 1 upon 8 plus 1 upon 16 minus and so on. The first term is 1 and the common ratio is minus 1 upon 2 upon 1, that is minus 1 upon 2. Hence the sum to infinity is a is 1 upon 1 minus r. R is minus 1 upon 2, so minus minus plus 1 upon 2. 1 plus 1 upon 2 is 3 upon 2 and 3 upon 2 reciprocal is 2 upon 3. This is our final answer. So 2 upon 3 is the sum of part B. Move to part C. Part C is 8 plus 8 upon 5 plus 8 upon 25 plus 8 upon 125 plus and so on. So the first term is A, that is 8. The ratio is 8 upon 5 divided by 8, that is 40 upon 5, and 40 upon 5 is 8 because 5 8s are 40. Hence sum to infinity is A 8 upon 1 minus R kindly wait, something, sorry, I did a mistake. This 8 multiply by 5, so 8 upon 40, sorry for this, 8 ones are 8, 8 fives are 40. So 1 upon 5 is the ratio. 1 upon 5, 8, 5 ones are 5, 5 minus 1 is 4, 4 upon 5, and then 5 8s are 40, 40 upon 4, 4 10s are 40. So 10 is the final answer. So keep in mind, when we divide, when we see the double fraction, we always multiply the last two numbers, and when we have a double fraction, after taking the LCM, we multiply to the last to the first, that is 5 8s are 40. Move to last part D. Part D is minus 162 plus 108 minus 72 plus 48 and so on. The first term is A, that is minus 162. The common ratio is 108 upon minus 162. Use the scientific calculator to find the answer in terms of fraction. That is minus 2 upon 3. Hence the sum to infinity is A minus 162 upon 1 minus R. R is already in minus, so minus minus plus 2 upon 3. So minus 162, 3 ones are 3, 3 plus 2 5, 5 upon 3. This 3 multiplied by minus 162, it is minus it is 486 upon 5. The answer is minus 97.2. A final answer. So this is question number 1. We did all parts. Move to question number 2. You must keep in mind the formula of sum of infinite geometric series, that is S infinity is equals to A upon 1 minus R. Question number 2. The first term of a geometric progression is 10, that is A is equals to 10, and the second term is 8. Second term means AR, because we have the formula AN or TN is equals to AR to the power n minus 1. AN is equals to AR to the power n minus 1. So for second term, you must put n is 2, 2 minus 1 is 1, therefore second term represent AR. So a is 10. Put this 10 over here. Therefore r is equals to 8 upon 10. 2 fours are 2 fives are. So r is 5. Hence s infinity is equals to a upon 1 minus r is equals to a 10. 1 minus r is 4 upon 5. 10 upon 5 ones are 5 minus 4 is 1 upon 5, and 5 tens are 50. So 50 is our final answer. Very easy question. Move to question number 3. The first term of a geometric progression is 300, that is a, and the fourth term is minus 2 whole 2 upon 5. So fourth term t 4 minus 2 whole 2 upon 5. So what does it mean t4? We use the formula an, or you can say tn, a r power n minus 1. Tn means t4, a r power 4 minus 1, that is a r cube. So t4 means a r cube, which is equals to minus 2 whole 2 upon 5. So minus 5 to the minus 10 plus 2 minus 12 upon 5. Now a is 300, so put 300 into r cube is equals to minus 12 upon 5. So r cube is equals to minus 12 upon this 300 must be divided. So minus 12 upon 300 into 5 is 1500. So r taking cube root on both sides. So minus 12 upon 1500 cube root. Use scientific calculator to find the answer in terms of fraction. The answer is minus 1 upon 5. So r is minus 1 upon 5. Hence s infinity is equals to a upon 1 minus r. A is 300. 1 minus r, minus minus plus r is 1 upon 5. 5 ones are 5. 5 plus 1 is 6. 6 upon 5. And this 5 must be multiplied by 300. It is 1500 upon 6. The final answer is 250. So the requirement has fulfilled. The common ratio is minus 1 upon 5, and the sum to infinity is 250. So very interesting question, very important according to examination point of view. The first four terms of a geometric progressions are 1, 0.8 square, 0.84, 0.8 power 6. Find the sum to infinity. Very easy. A is the first term 1, r is 0.8 square upon 1, that is 0.8 square. The sum to infinity formula is a upon 1 minus r. A is 1, R is 0.8 square. The answer is so 1 upon 1 minus 0.8 square is 9 upon 25, or you can write 25 upon 9, or you can write in terms of mixed numbers 2 whole 7 upon 9. So this is our final answer. Question number 4. Move to question number 5. Question 5 part A. Write the recurring decimal 0.4 dot 2 dot as the sum of geometric progression. It is very easy. Student, focus on these two dots. 0.42, the dot on 4 and the dot on 2 means the first term of the sequence is 42 upon 100. Why? Because the place value is 100th. Unit 100th. So it is called a recurring decimal. The second value must be 42 upon 1, 2, 3, 4, 5. Why? I will tell you the answer. The third value is 42 upon 1, 2, 3, 4, 5, 6 plus and so on. So students, this is called a vulgar fraction. So first term 0.42 means it is the 100 place. So we have to write 42 upon 100. Then move to 100. What I write? 100,000. So multiply by 100. Then again multiply by 100 and so on. I hope you understand. So this is the answer of part A. But if you feel any problem, I will help you. Use your answer to part A to show that 0.42 recurring decimal can be written as 14 upon 33. Very easy. Sum to infinity 42 upon 100 and R is 42 upon 100,000 divided by 42 upon 100. So 42 upon 100,000 into 100 upon 42, because fraction can be reciprocal after turning the divide sign into multiply. 42 by 42, 20 cancel by 20. So the answer is 1 upon 1000. This is R. Hence sum to infinity is A, 42 upon 100 upon 1 minus R, that is 1000. 42 upon 100. 1000 multiplied by 1 is 1000 minus 1 is 999 upon 1000. So 42 upon 100 multiplied by 1000 upon 999. So these 20 cancel by these 20. So it is 42 into 10 is 420 upon 999. Use the calculator. Sorry, one mistake which I did, because kindly wait. 100 by 100 is 10,000. So 10,000 means 40, then 60. So this is also wrong. This is 20. So 20 cancel by 20. Answer is 1 upon 100. Sorry, 1 upon 100, not 1000. This is my mistake. 1 upon 100. So 100 ones are 100. 100 minus 1 is 99. So 42 upon 100 upon 99 upon 100. So I am doing this little work again. So 42 upon 100 multiplied by 100 upon 99. 100 cancel by 100. The answer is 42 upon 99. Use scientific calculator. The answer is 14 upon 33. And this is our final answer. We have proved the requirement of part B was use your answer to part A to show that 0.42 vulgar fraction can be written as 14 upon 33. So the important point is the place value is 100. So we have to write 42 upon 100, then multiply by 100, then multiply by 100, and so on. I hope you understand. Question 6. The first term of a geometric progression is minus 120. That is, a is equals to minus 120. And the sum to infinity is minus 72. Find the common ratio and sum of the first three terms. Very easy. So the formula of sum to infinity is a upon 1 minus r. S infinity given is minus 72. A is given minus 120 upon 1 minus r. So minus cancel to minus, 1 minus r can be multiplied, and 72 should be divided. So 120 upon 72 is 5 upon 3. So 1 minus 5 upon 3 is equals to r, and r is equals to 3 1 3 minus 5 is minus 2 upon 3. So minus 2 upon 3 is the value of r. This is the requirement, first requirement. Now sum of the first three terms. So we use the formula of Sn is equals to a into 1 minus r to the power n upon 1 minus r. This formula is used when we have r is less than 1 and in geometric sum of infinite geometric series r is always less than 1. So first three terms means s3. A is minus 120. 1 minus r we have find minus 2 upon 3 to the power n is 3 upon 1 minus r. R is already in minus plus 2 upon 3. So minus 120, 1 minus to the power odd number is always minus, so it is minus plus 2 power 3 is 8 upon 27 upon 3 ones are 3 plus 2 is 5 upon 3. So minus 120, 27 ones are 27 plus 8, 35, 35 upon 27, and this 5 upon 3 becomes 3 upon 5. So 5 sevens are 35, 3 nines are 27. So minus 120 into 7 upon 9. I am doing the remaining work over here. The answer is minus 280 upon 3. Minus 280 upon 3. And this can be right in terms of mixed number. It is minus 93 whole 1 upon 3. This is our final answer. So actually this is not the requirement to write the answer in terms of mixed number, but because the answer in the book is given in terms of fraction, and students says that the answer of your answer is wrong, so my answer is not wrong, but I don't like to write the answer in mixed fraction. But because the requirement, therefore I am fulfilling the requirement of the answer in the book. The second term of a geometric progression is 6.5, that is T2, and the sum to infinity is 26, that is S infinity. Find the common ratio and the first term, that is A. So T2 means AR, that is 6.5. S infinity means A upon 1 minus R, that is 26. So work on this fraction A. This 1 minus R should be multiplied 26. So 26 minus 26 R. Now take this. AR is 6.5, or you may write A is equals to 6.5 upon R, or put this value of A in this equation. So A is 6.5 upon R is equals to 26 minus 26R. So 6.5 is equals to R into 26 is 26. R into 26R is 26R square. Shift these two numbers on this side. It is 26 R square minus 26 plus 6.5 is equals to 0. Now we have to solve this quadratic equation. Because this is in terms of point decimal, so I suggest you to use the quadratic formula. I am writing answer directly. So the first answer is 1 upon 2. R is 1 upon 2. And the second answer is 26. But students, we will take this answer because in infinite geometric series r is always less than 1. So r is 1 upon 2. When you use the quadratic formula, you will have two answers. So you have to take the answer which is in terms of fraction. So our final answer is 0.5. Next is to find the first term. Very easy. Put this value of 0.5 in any of the equation, right? Like I am putting in this equation, AR is equals to 6.5 and A is equals to 6.5 upon R. 6.5 upon R is 0.5. The answer is 13. So R is 0.5 and first term is 13. This is our final answer. This is our today's class where we did first 7 questions of exercise 11.5. I hope you enjoy a lot from this exercise. This is the whole summary of question number 7. How many questions are left? Question number 8, question number 9, question number 10, 11, 12, 13, 14, 15 and 15. So we can do remaining questions in next 2 lectures. So this chapter is going to end 11.6 and yes, so only one exercise will be left after 11.5, and after this chapter we will be doing a most important chapter, that is differentiation. So I hope you enjoyed today's class. So if you think that my videos are helping you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I excuse me, so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Good luck for next lecture.